my name is Ryan Kurtz, and today we're going to be talking about balancing equations. We know enough about equations, and what an equation does is it describes a reaction. So to start off, we're going to be looking at H2 plus O2 equals H2O, which we know is water. So first thing we're going to do here is I'm going to count how many atoms are on each side. So on this side, we have 2 hydrogens, 2 oxygens. So that would equal 4. And on this side, we have 2 hydrogens, 1 oxygen, because this is implied. It's a 1. So we have 3. So we know now that this equation is not balanced properly due to the law of conservation of matter, because matter cannot be created nor destroyed. So first thing we're going to do is we're going to draw out how many of each atom we have on each side. So on this side we have 2 H's, and on this side we have 2 oxygens. Okay, now on this side of the arrow, or the reaction, we have 2 hydrogens, but only 1 oxygen. So what we need to do is we need to get the oxygens on this side the same as the oxygens on this side, and the hydrogens and the hydrogens. So to do this, we're going to multiply each of the molecules, molecule, to make it so it'll equal out. So first thing we'll start doing is noticing that we need to make the oxygens equal out. So that's our first problem here. The hydrogens actually already equal out. So to make oxygens get to 2, we are going to add another, so we're going to have 2 H2O molecules on this side. So doing that will give me 2 times 2 hydrogens, which is 4, and 2 times 1 oxygen, which is 2. So now we have a problem. We matched up the oxygens, but now that messed up our hydrogens. So what we're going to need to do is we're going to need to get this to 4. So we'll take the hydrogens here, we'll double it. So now we're doing 2 times 2, which equals 4, and that checks out. So that was a rather simple example. So let me change the equation so we get a little tougher. All right, so now we have another equation. This one gets a little bit harder. So first thing we do is count how many atoms we have on each side. So here we have N2 plus H2 equals NH3. So I'll start by counting the N's. We got 2 as here, and H, we have 2 here. And on this side, go in the same order, we have only 1 nitrogen, and we have 3 hydrogens. So here we actually have 4 and 4, but doesn't quite line up. We have 2 nitrogens here and 1 over here, and we have 2 hydrogens on this side and 3 on this side, which does not match up. That is not a proper equation. So first thing we're going to do, I like to start out with the most complicated molecule. So we have, this is a single, but here we have 2 in the molecule. So we want to manipulate these ones first because these are easier to manipulate. So it seems like maybe we can, what I like about these is it's guess and check. So you can throw in numbers and see what you get out with until you find it. So we have two ends here and one end over here. So what I'm going to try and do first is I'm going to double that. But that gives us, so we'll have 2 implied 1 nitrogen here. So that would be 2 nitrogens. And we got 2 times 3, which is 6 hydrogens. Now, as you can see, the nitrogens line up nice, but the hydrogens are still quite off. We have 6 over here and 2 over here. So, as you can maybe predict yourself, we are going to times the hydrogen molecules by 3, because 3 times 2 equals 6, and that's what we're trying to get. So now the answer will be 3 here and 2 here, and now we are all equal. We got 2 nitrogens, 6 hydrogens, 6 hydrogens. And we will do one more example. We'll get a little bit harder, and then I'll let you guys go. All right, so what we have here is quite a bit harder equation to balance. This is actually the equation for photosynthesis, if you were wondering. So let's get to it. So also sometimes when balancing an equation, it's nice to just draw a line between where the area is, just to keep your sides separated. So like always, we're going to start by counting each individual atom and on each side. So on here we have carbon, so we have 1 carbon, implied 1. If there's no number there, that means there's just 1. So we have 1 of those. Oxygens, we have to count these ones and these ones since it's still on this side. So oxygens, we have 1, 2, 3. And then H is next, and we have 2 of those. Alright, so now we're going to count in the same order. So we got C, O, H. So we're going to count all the carbons on this side, which we have 6, as seen here. Alright, and then we have oxygens. We have some here and some here. 6 plus 2 is 8. And we're going to count our hydrogens, which this is the only place hydrogen is, so we got 12. So now that we have all that, so what I'm going to start with is I'm going to try and get the carbons, since there's 1 here on this side and 6 on this side. I'm going to try and just get that to equal the carbons, because that's the easiest thing to do at this point. So to get 1 to 6, you times 1 by 6, obviously. So what you then have to do is times the carbons by 6, but you also have to times the oxygens by 6, because they're in the same molecule. So at this point, we have 6 carbons, which is what I was trying to get, but we also have, so we have 6 times 2, which is 12, plus the one over here, which is 13. And then hydrogens will still be the same because they have been untouched thus far. So we have the carbons checked out. Now we need to get another molecule the same. So at this point, to get from 13 from 8 to 13 is not going to be very simple, but to get from 2 to 12 to equal out, that'll be a little bit easier at this point. So hydrogens are right here, so I'm going to have to times this molecule by something to get to 12, which will be 6. 6 times 2 is 12. So I'm going to put a big 6 here, and again, we have to times the H's for hydrogens by 6. We also have to do the oxygens again by 6. So now we have 12 hydrogens, which is what I was going for again. So that checks out now. But we have to count up all the oxygens. So we have 6 times 2 here, which is 12. And we have 6 times 1 here, which is 6. So we have 12 plus 6 equals 18. So now, last thing to do is we need to get the oxygens equaled out. So what I'm going to try and do is I'm going to throw in a number here. Let's try 4. So now we have to count up all the oxygens on this side, which will be 4 times 2, which is 8, plus the 6 that are still here. So we have 14 oxygens. And as you can see, we need 18, so we need to try a different number here. It's easiest to manipulate this one because the oxygen is alone, whereas here we would have to times all the carbon and the hydrogens by the same number, and we don't want to do that because then that would mess up all what we've already done. So I'm going to erase this. It's kind of the guess and check game. And I'm going to try 5. So now we have 5 times 2, which is 10, as well as 6. So now we have 16. 6 plus 10, 16. We're still 2 away from being equal. So we're going to try one more time. I think we got it this time. I'm going to put in a 6. So now we have 6 times 2 oxygens, which is 12, plus the 6 that are here, that's 18. And now we have all of our elements checked out, and we have balanced the photosynthesis equation. So our numbers would be 6 CO2s, 6 H2O, and 6 O2. And then this we can just leave at 1, or unchanged. All right, thanks guys.